Alright, here we have two special triangles, the ones that we've been dealing with. And the first one here is isosceles, and it's going to be 45 and 45 degrees, which means that the opposite sides have to be the same. Something that comes out of this then is that, in fact, if I take this and I say, well, let's find out what the hypotenuse is over here. To find out the hypotenuse, I'm going to say, well, that's x squared plus x squared. And that's going to equal, I'm going to call it h for now. So that's going to equal h squared. Well, to solve this further, x squared plus x squared is actually 2x squared. Okay, so 2x squared will equal h squared. And last but not least, I'm going to square root all this, in which case I'm going to get here that this will become the root of 2 times x will equal h. I'm going to rewrite this and just call it x root 2. And this will equal h. So in other words, this will be x root 2. What this says to us is that for any triangle, or any, 45, 45, 90 degree triangle, these two will be the same length, and this will just be x times root 2. But we get a different scenario with the 30, 60, 90 triangle. And if I look at this as the shortest side, the reason I know that this is the shortest side is because it's opposite this 30-degree angle. And so this has to be the shortest. This would be the second, and this would be the longest. Okay, because it's the hypotenuse across from the 90. When I do this one, something different happens. In fact, if this is x, this ends up becoming 2x. And these will always be this will always be this relationship. This will always be double. If this is x, this one's a little bit different. This one will end up becoming x root 3. And so this across from the 60 will always be root 3 times what this value was. That's the length of this. And this is the relationship always between these. Knowing these is actually quite useful because I can do a lot of easy calculations like as follows. If I have, let's say, a couple triangles here, I'm going to say that for this one, let's make it a 45, 45, 90. And suppose I knew that this was 5. The length of this is 5. Well, the nice thing is then I know that this is 5. And I also know then that this is 5 root 2. And it's really easy just like that. Just like we had before. We put x and it was these values. Well, now if I know the value of x, I can find everything else. Sometimes you might get the scenario here with the 45, 45, 90, is you might get the scenario where we know what this is, and maybe this is 10. And I ask you for these two. Well, we know they're the same, but remember how we got from here to here. From the leg to the hypotenuse, we multiply by root 2. So it makes sense to go from the hypotenuse to the leg. We're going to divide by root 2. Okay, so both of these will be 10 divided by root 2. And by the way, we don't like to leave what are called radicals, or these numbers under the square root, on the bottom. So we try to get rid of those. I'm going to show you how to do that in a separate video, but needless to say, when we do this, we want to eliminate that. So I'm going to say here that 10 over root 2, if I multiply that by root 2 over root 2, what I'm going to get here is 10 root 2 all over 2, which equals 5 root 2. Again, I'm going to explain this later on, how to get rid of radicals, but my final answer should be 5 root 2 for this one. Okay. Same thing is for the 30, 60, 90. The 30, 60, 90, okay, let's say this is, I'll make this guy 30 and this guy 60, not to scale, but if I have this one and I say to you, well, suppose we knew that this answer here was 7. And I said, well, what are these two? Well, if that's 7, okay, this has got to be 14, because again, that's across from the 30. Again, that's the shortest side. May not look like it, but if it's across from 30, it's the shortest. If that's 7, then this one is 7 root 3. And you can reason it out how to get these ones as well next time. But essentially, we're replacing x here to get those final answers.